Physics is based on the measurement of physical quantities. But the problem is, whenever a quantity is measured, there is naturally some uncertainty about its measured value. There are multiple reasons for the uncertainty. We discussed some of those reasons in the previous video. One major reason I'm going to talk about is the type of instrument used and its calibration. You know that every instrument has a least count, the smallest value under which it cannot measure. This puts a limit on the degree of accuracy which can be achieved through that instrument. I know it sounds a bit confusing. Let me give you an example. Suppose we measure the length of a straight line with the help of a meter rod calibrated in millimeters. We see that one endpoint of the line is in between 10.3 and 10.4 centimeters mark while measuring. It is a rule that if the line does not touch or cross the midpoint of the smallest division, then it is confined to the previous division. But if it exceeds the midpoint, the reading is extended to the next division. But doing so, there comes an uncertainty of 0.05 in the measurement, right? Now, if the line is measured as 12.7 centimeters by a meter rod calibrated in millimeters, then the line's actual measurement is between 12.65 and 12.75 centimeters. This difference of 0.1 centimeter is the least count of measuring instrument divided into two parts, half above the recorded value and half less than the recorded value. This uncertainty in measurement can easily be indicated using significant figures. To understand what significant figures are, let's go back to the previous example. The measurement of the line recorded by meter rod is 12.7 centimeter. But in the actual case, the line's length is between 12.65 and 12.75, right? If you compare actual and measured values, you will notice that the first two digits, 1 and 2, are the same. We call them the accurately known digits. The difference starts with the third digit. This third digit is the first doubtful digit. So, in any measurement, all the accurately known digits and the first doubtful digits are called significant figures. The significant figure is one that is reasonably reliable. For example, the measurement 12.7 centimeter has three significant figures. If instead of meter rod, we would have used a more precise instrument that could measure up to 1/100th of a centimeter, then the measured value would be 12.70 centimeter with four significant figures, which is more precise. In short, we can say by improving the quality of the measuring instrument, the accuracy of the result is increased, and so are the significant figures.